Good morning. This is Mr. Culp again, and we are going to be going over currents today in our notes. So get out your note packet and get ready to learn about science. All right, wonderful. So let's begin. What is an ocean current? Well, most of you probably remember back in middle school, ocean currents are when the ocean water moves from one place to another. And for those familiar with the movie Finding Nemo, the scene where the clownfish with the turtles travels all the way on the East Australian current to Australia. So they're traveling in a current in the South Pacific, and it's very similar to what the movie shows you. It's not as fast, but that's typically what the current is. All right, they can be on the surface of the ocean or deep underground, or not deep underground, but deep under the ocean. And we're going to talk about the difference today. So most of you know that China manufactures a large amount of material that is used by the United States. And one example of that are rubber duckies. Every so often a cargo container will fall off the boat and burst open in the water and kind of just linger there. Well, a few years back, a cargo container filled with thousands and thousands of rubber ducks opened up, fell off the boat, opened up, and those ducks were found all over the world from different types of currents, carrying them from one place to another. So surface currents, that's what we're going to talk about today, the first part. So friction is the force of energy being transferred between two objects rubbing against each other. So when the wind blows over the surface of the ocean, you have a bit of energy get transferred. This creates what we like to call surface currents. So that East Australian current in Finding Nemo would be a good example of a surface current. It's moving horizontally across the ocean. And once again, the winds are created by solar radiation. So the sun is kind of powering this. We also get gyres. So gyres are large whirlpool-like features in the ocean. Now, it's not a traditional whirlpool, what you think of. It's just a large spinning current that goes around the ocean. And there's 5 gyres. One in the North Pacific, one in the South Pacific, one in the North Atlantic, one in the South Atlantic, one in the Indian Ocean, and then you have one that kind of goes around Antarctica as well. But those are the gyres. And you'll notice that you have different arrows in our picture. The red arrows are warm water, and the blue arrows are cold water. And as you can see, it's kind of mixing the water together. Like the red water is pushed northward, away from the equator. Your warmer water is being pushed away from the equator, and your cooler water is being pushed towards the equator. So that does a good job of kind of helping to mix up the weather systems. So why do they move in a circular pattern? This is known as the Coriolis effect. So you can imagine if you were in a cannon and you were shot out of the North Pole towards the equator. If the Earth wasn't moving, you would go in a straight line and you would land wherever the cannon was pointed at. But because the Earth is moving and rotating, if you're shot out of that cannon, you're going to not actually hit what you're pointed at. You're going to hit slightly east of that. So the Coriolis effect is caused by the rotation of the planet underneath the atmosphere. And once again, because your surface currents are created by wind, this movement and deflection of the wind and rotation of the wind causes our gyres. So in the northern hemisphere, they're deflected to the right, and in the southern hemisphere, they're deflected to the left. You can kind of think of it as clockwise and counterclockwise. So ocean currents and climates, as we saw in our last picture, 2 pictures ago, we have a great mixing of water. Warm water at the equator is pushed towards the poles, and cold water at the poles is pushed towards the equator. This mixing of water and air will actually transfer energy from low latitude areas, that's places near the equator, to high latitude areas, that's places near the poles. and vice versa. Now, when we look at our little picture here, we'll notice that we have two countries. We have England with a little green dot on it, and we have Canada with another green dot on it. And there's Stornoway in England and Hopedale in Canada. Now, when you think of northern Canada, you probably think of very, very frigid, cold places, a lot of snow, probably some moose. Not an incredibly pleasant place to be. When you think of England, you might think it's rather cool and chilly, but you don't think it's a frozen wasteland like northern Canada is. Well, the reason why that occurs is because of the Gulf Stream. We have the Gulf of Mexico, which is a sea down near the Caribbean, and we have warm water from the Gulf being pushed up because of the North Atlantic Gyre towards England. Now, as it's being pushed up to England, it'll slowly transfer some heat energy into the atmosphere, which warms up the air, thus kind of raising the temperature of your weather. So your ocean currents can actually affect your weather. Now, the opposite happens if you're on the west coast of a continent. Usually, when you think of California, for example, you think of the water around Seattle or Portland or San Francisco, and the water tends to be rather chilly. And the reason for that is because your water, instead of coming from the equator, is now coming from the North Pole in Alaska. And as you can imagine then, that water is rather chilly. So that lowers the temperature of the air. So it can do one of two things. You can raise the air temperature or you can lower the air temperature. And it depends on where your currents are coming from. In our picture here, we have North America. And as you can tell, the coastlines, the East Coast and the West Coast, are warmed up compared to the inner side, the middle of the continent. Now, the oceans take a long time to warm up and they take a long time to cool down. So if you've ever gone to the beach at the beginning of summer, you might notice the ocean is rather chilly and cold and it's not a lot of fun to be in. Well, you can think that the ocean has been cooling off and giving off all of its energy over the course of the winter. And at the beginning of the summer, it has not had any time to warm up yet. Conversely, if you've ever gone to the beach in August or in the late summer, you'll notice that the water is very warm and it's very pleasant and nice. Well, the ocean's been warming up all summer, so it is nice and warm. So the ocean takes a long time to warm up, but it also takes a long time to cool down. And because of this, it kind of helps to stabilize your air temperatures. So that keeps your summer days from getting too hot, and it keeps your winter days from getting too cool. So that's why you usually have milder temperatures at the coast. All right, so we've talked about surface currents. Now we're going to talk about density currents. So density currents are currents that are vertical. They move up and down, and they're caused by differences of density. If you remember what density is, it's the amount of matter in a given space. So what can affect our density? Well, there's two main things: the temperature of the water and the amount of salt in the water. Now, it's kind of unusual to think about, but if I can make denser water by decreasing the temperature. So if I decrease the temperature of my water, my density is going to increase because the molecules aren't moving as much. And because they're kind of calming down, that's what temperature is. It's how fast the molecules are moving. Because it's so much cooler, the molecules are kind of coming together and squeezing together. And they're becoming more stuff in the same amount of space. By increasing the salinity, I can also increase my density. The salinity is the amount of dissolved material in a liquid. So if I'm just adding more mass to the given amount of space, I'm increasing my density. So you're probably asking yourself, where would I find the densest water on the planet? Well, we have to remember, decreasing the temperature makes our water more dense, and increasing the salinity makes our water more dense. So where will we find the coolest, saltiest water? And that would be up near Antarctica. So in Antarctica, you have incredibly, incredibly cold water, and you have incredibly salty water. And because of those two things, you're going to have very dense water. And at the end of this, your teacher will show you this video of an icicle of death. It's rather interesting to see what happens when super cold, chilly, salty water interacts with the water around it. So these currents are generated by your changes in density. So evaporation can increase your salinity. And I had to apologize on this slide. It actually should say raising water density. So if you increase your salinity, you're raising the water density. You're not lowering it. So on your notes, please make sure to correct that and to put the correct answer. But in our little our rubber ducky simulation, we noticed that the rubber ducks went all over the world. So they weren't just confined to the North Pacific. They made their way down to the South Pacific. They made their way over to the North Atlantic. So they traveled a great deal. Well, if you look at our picture, we notice that the ocean acts like a gigantic conveyor belt. And any water molecule can at some point over the next billion years travel to literally anywhere else on the planet. So your water isn't stuck in one area. It's very fluid, obviously, because it's liquid. A last thing we were talking about today is upwelling. So when we have these density currents, and they interact with our continental margin, which is that continental crust covered by ocean water, and it strikes the continental margin and get pushed up. And at the same time, wind from the coastline drags surface water away. We get something known as upwelling. So upwelling is the rising of cold, nutrient-rich water near your coastline. Now, there's lots and lots of nutrients in the water. Well, what does that mean, Mr. Culp? Well, what that means is that because you have a lot of nutrients, a lot of raw minerals, plankton, you have a large amounts of plankton. And remember, plankton is the very base of the food chain. So if you have more plankton, you have more fish that eat plankton, and you have more fish that eat the fish that eat plankton, and so forth and so forth. So by having these upwelling areas, they're very good for the ecosystem, and they're very good in creating a healthy place to live. So once again, your deep ocean water is very rich in nutrients, and as it is brought to the surface, it creates plankton blooms, which help benefit your animal life. And the importance and the impact of upwelling is it helps keep the ocean healthy. So any place with a lot of life, it's a healthy ecosystem. It's good. There's life, lots of healthy animals. Good for humans too, because we rely on the oceans in that manner as well. Well, thank you for watching today. I hope you have a great rest of your class period and study hard.